Hi everyone, I'm back again. I'm here to try to solve, actually not solve, but I'm gonna do number 42, trap rainwater, as a refresher to practice my speaking as well as my problem solving skills. This is a classic problem. I think a lot of people have gone through this problem before. It's always a good refresher. This is a hard problem and one of the most well-known problems in all of LeetCode. So let's get started. Trapping rainwater. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Okay, so you're given height 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1, which gives you this elevation map. And after raining, you basically trap 6 squares of rain, right? 1, 2, 3, 4, 5, 6. Okay, and so you need to return 6. And they give you another elevation map. They didn't draw it to visualize, but they tell you that the answer is 9. Okay, so the first thing that you need to realize, there are a couple tricks that you need to realize with this problem, is that number one is that when you have 1 or 2 bars, right? I'm going to just call these things bars, okay? I know it says elevation map, but I'm going to call these numbers just bars. If you have 1 or 2 bars, there's no way that you can trap any rainwater, right? If height is of length 0 or 1, if height is of if you have just like 1 or 2 bars, I don't think you can trap any rainwater. Let me check that. Right, that's true. Because you need at least 3. Height needs to be of at least value 3 before you can trap any water. And the second thing is that whenever you're able to trap rainwater between 2 bars, right? Notice that the minimum one is the one that determines the water level, not the maximum, but the minimum one is the side that determines the water level. And this is the width is 1, so that's never going to change. And look at all this, right? This is pretty complicated. This T-shaped is pretty complicated to figure out, like, what the water is. There's changes, there's elevation differences. So instead of thinking about trying to calculate this whole T all at once, you can think about, like, at this bar, what is the water that's been trapped right here, which is 1, right? At this bar, how much water is trapped? Two units of water. At this bar, how much water is trapped? There's one unit of water. So whenever you see like these huge big puddles of water that's been trapped, you should think about how you can solve it via each individual bar and how much the bar of water has been trapped above it, such that once you sum all the bars of water that's been trapped, that will give you the answer. Okay, so those are some of the tricks to the problem. Let's get started. So the n equals height dot length. 1 is less than or equal to n, which is less than or equal to 2 times 10 to the 4th. And you know that 0 is less than or equal to height 1, which is less than or equal to 10 to the 5th, right? Let's take a look at the constraints. Okay, n is the height dot length, right? It's basically telling you that the height list can be pretty unwieldy. It can get pretty long. 2 times 10 to the 4th is pretty big list. It's a very, very long list. So some brute force approach is definitely not going to work. 0 is less than or equal to height of I, which is less than or equal to 10 to the 5th. this basically says that the values themselves can range from as low as 0 to as high as 10 to the 5th, which is typical. Let's take a look at the topic. This is a 2-pointer problem. But let's take a look at what they say. Oh, you can solve this problem in a multitude of different ways. This is an array, 2 pointers, dynamic programming, stack, or monotonic stack problem. You can solve this problem in many different ways, but I'm going to do the 2 pointers approach, right? So how do you solve this, right? So first is you have to define left max and right max. Define left and right. So you have to define the left and the max heights, which are the heights of the current bars, and the left and the right pointers are gonna loop through from, let me write this down. The left and right pointers are going to loop from 1 to n minus 2, where n is the length of height, right? So basically what that's saying is that you set the left maximum of the left and the maximum of the right. Those are the 2 bars. And as you're doing that, you're doing a 2-pointer problem from the first index to the n minus 2 index, where n is the length of the height. Check if left max is less than right max, right? You want to find the lower of the 2 bars to then do you want to find the lower of the 2 bars because that defines the water level. Check if left max is less than right max. Check if left max is less than height of left, right? You want to see if this bar right here is going to be, if it's you want to check the 2. Imagine there were 2 bars right here, right? Imagine there were 2 bars. You want to check if this one, the first one, is less than the second one, right? If that's the case, then you know that you found another bar. If that is the case, then update left max. Imagine there were 2 black bars right here. This is the first one, and there was another black bar that's higher than this one located right here. Imagine the blue square is gone and there was another high. When you have a smaller bar first and then a larger bar, there's no way you can trap any water. So you have to update the max on the left side to this new one, because only the new one could potentially trap water. This one is irrelevant anymore, right? But if this one is higher than the second bar, the first black bar is higher than the second black bar. Imagine this one was a few units higher and the blue is gone and there's a smaller black bar right here. That means that this one you can actually trap some water, right? Above this one you can trap some water. So if that, the other case is that else update the trapped water count, because you did trap some water above this bar. Like I said, you want to calculate the trapped water above each and every bar, right? Increment the left pointer. So this is what we're doing for the left, and then else, right? We also have to do it from the right side. Everything we did is just from the left right now. Now we have to move on to the right side. Else, do the same thing for the right side. Write the same code by the principle of symmetry, and once you have both the right and the left side working, this logic to check the trap water above each and every bar, updating the left max and the right max, and then seeing for each bar whether above it you can trap water, then you can be able to return the answer. So let's get started. Okay. ANS equals 0. Max left, max right equals height 0. Height, let me define something else. N equals len height of n minus 1. Okay. And then you have left, right equals 1, n minus 2. While left is less than or equal to right, you have to check among the two which is the lesser one, the left max or the right max. Yeah, I actually wrote this wrong. Left max, right max. You have to check among the two which is the lesser one, because that determines if this is left max and this is right max, the smaller of the two determines the water level. So if left max is less than right max, you know that the left max is the one that determines the water level. Now you can have this check on the current left max if you trapped any water, right? If left max is less than height left, right? If the left max is less than the height, this is the 2-bar thing that I was telling you about. If the left max right now is less than the height of the next bar next to it, then you can't trap any water, so you have to update left max. Left max equals height left, right? Else you can trap water. So then answer plus equals the left max minus the height left, and then you have to increase the pointer. L plus equal 1, right? That's for the left case. Now let's do the same thing by the principle of symmetry for the right case. If right max is less than height of right, then you do the same thing. Right max equals height right. Else, answer plus equal right max minus height right, and then you have to update the pointer. Right minus equal 1. I think if you return answer, that's it. Let's see. Whoops. Left, right. Okay, there we go. So this problem, I solved it, and the time complexity is O of n. You're going through the height array one time, and the space complexity is O of 1, because you're not defining any new data structures to hold things. No new lists, dictionaries, sets, etc. This is a very good problem. It's not, I wouldn't say that it's labeled hard, and it is very tricky, but it's very doable. There are other solutions, as you can see, with I did the 2 pointers. There's also dynamic programming stacks, monotonic stacks. Those can get pretty unwieldy, but this is a solution that made sense to me, and I enjoy doing it. So thank you very much, everyone, and I'll see you at the next one.